first challenge, we connected an LED to pin 9 on the Arduino. The code made the LED blink on and off repeatedly. It was simple, but it helped us understand how digital output works. For challenge number 2, we use a PWM pin to control brightness. The LED gradually fades in and out, giving a smooth lighting effect. For challenge number 3, we connected 2 LEDs to pin 8 and 9, each with its own resistor. They blink alternately, switching on and off in a sequence. For challenge number 4 setup, we added a push button connected to pin number 2. Pressing it turns the LED on and off. For challenge number 5, we connected a potentiometer to analog pin A0 to adjust brightness. Turning the knob changes voltage, making the LED dim or glow brighter. Since it was our first game, one of the main difficulties we faced was connecting the components correctly. Sometimes, the LED didn't light up because we placed them in the wrong way or missed a resistor connection. Despite these issues, we learned how important proper connections and timing are when working with basic circuits.
이제 게임을 시작합니다.
In our first challenge, the buzzer was connected to pin 9 and activated with a button. When pressed, it produced a short beep. The circuit in challenge 2 played a short melody when powered. We connected the buzzer and copied the code from the lab manual to generate notes. In challenge 3, we used the buzzer to transmit SOS in Morse code. Short and long beeps represented dots and dashes. In challenge 4, we added a photoresistor that triggered the buzzer when light intensity changed. The sensor was connected to analog pin A0. In challenge 5, we used a potentiometer to vary the buzzer's pitch. Turning the knob changed the tone in real time. In our second game, one of the main challenges was getting the sound output to work properly. At first, some buzzers didn't make any sound because of loose connection or incorrect wiring to the Arduino pins. However, we countered those by fixing our wiring.
이제 게임을 시작합니다.
We connected each segment to separate digital pins. Lighting the correct segments displayed a single number, which is the number 3. In challenge number 2, the display cycled from 0 to 9 automatically. For game number 3, or the 7th segment display game, our main difficulty was identifying which pin controlled each segment. The wiring was confusing at first because there were so many connections going to the Arduino. Organizing the wires and labeling connections helped us fix the mistakes and thus understands how each segment forms different digits. For task number 1, which is the dancing lights, we created a series of LEDs connected to different digital pins on the Arduino. The lights were arranged in a row on the breadboard to form a simple light pattern. When the program runs, the LEDs turns on and off in sequence, creating a dancing effect that looks like moving light waves. One challenge was organizing the wires since multiple LEDs meant more connections. It was easy to mix up pins, so we double-checked the wiring before uploading the code. In the end, seeing the LEDs blink in perfect rhythm was one of the most satisfying parts of the lesson. Here's the prompt we used for the code. And here's the flow chart on how everything would go.
Once the flow starts, is the correct Arduino sketch uploaded to control the LEDs turning on and off? If yes, the LED light will start to turn on and off alternately and one by one. If no, nothing happens to the LED lights. Do the LEDs keep on blinking? If no, the power supply was lost. And if yes, the LEDs continues blinking as long as the power supply is active. Is there a resistor limiting the current to the LEDs? If no, the LEDs may burn out if used continuously without protection. If yes, the LEDs remain protected and continue working normally.
For this task, we use a passive buzzer connected to one of the Arduino's digital pins to play a custom melody. The circuit setup was simple, just the buzzer's positive pin to the output pin and the negative to the ground. One of the challenges we encountered was facing the inconsistent sound output. Sometimes the buzzer produced distorted or even uneven tones, especially when the jumper wires weren't fully connected. Here's the prompt we use for the code. And here's the flow chart on how everything would go.
Start. Has the correct code been uploaded to the Arduino Uno to play the happy birthday melody? If no, the buzzer doesn't make any sounds due to incorrect programming. If yes, the buzzer will play the song Happy Birthday. Does the melody continue to play? If no, the power supply was interrupted. If yes, the buzzer continues playing as long as the power supply remains on.
Throughout the robotics class, we learned how small components like LEDs, buzzers, and displays can come together to create interactive systems. At first, the lesson seems complicated, especially with all the wirings and code. But as we worked through each activity, we began to understand how circuits, sensors, and logic all connect. Our perspective on robotics has also changed. It's not just about machines or programming. It's about creativity, experimentation, and learning through trial and error. Moving forward, we are excited to explore more advanced projects in the future, maybe even use sensors, and maybe even design our own robots. And of course, we have plenty of moments along the way, from small mistakes to big laughs, making this class an experience we'll always remember.